We only have 4 questions this week, but this last one is a long question, so that's why you only have 4. So we're looking at a residual plot between the age of a tree, which seems to be the predictor for the diameter. Now, I've said this before, you can't just walk out and ask a tree how old it is, but you can measure its diameter by measuring the circumference and then calculating the diameter from that. So it seems to me, just me, that this model is a little bit backwards here. We should be using diameter to predict age and vice versa. However, a forester would like to know how big a maple tree might be at the age of 50. So this is why they're using age. They're saying if a tree is 50 years old, how big could we expect it to be? She gathers data from some trees that have been cut down and plots the diameters of trees against their ages. How does she know how old they are? I don't know. First, she makes a linear model, and the scatter plot of the residuals are shown. You can see the scatter plot has a real curve to it. So let's describe the association. So remember, when we describe association, we want to talk about the direction, strength, and form. So in this case, I would probably say the association between the age of a maple tree and its, sorry, no, just its diameter is moderately, let's say moderately strong, positive. And don't be confused by this. This shows a line, but the data really, when we look at it, is curved. All right, so we would say strong positive and we would say curved. So that's why we're going to say it's not a great model. So do we think it's a good model? Sorry about that beeping here. There's a trash truck outside. So do you think the model is appropriate? So in this case, we could say, I would probably say no, because there's a curve in the residuals. And you could go on to say things if you wanted to. It seems that trees that are that have lower predicted ages are trees that are younger are actually predicted to be larger than they actually are, and trees that are in this middle age range are actually bigger than they're predicted, and older trees are again being over predicted. So the model tends to overpredict for younger and older trees, and it tends to underpredict for the trees in their mid-range. The next part is, if she uses this model to try to predict the diameter of a 50-year-old maple tree, would you expect the estimate to be accurate? And again, as the model moves further, older trees tend to be overpredicted, right? So we would say something to the effect of, so since the model overpredicts the age of older trees, we would expect the prediction of the diameter of a 50-year-old tree to be too high. We'd also expect there to be a negative residual, right? Because these are negative residuals right here. We can go in and say that if we wanted to. All right. So what do we do about it? Well, what they did was, looks like they worked with re-expressed the data using the logarithm like we did in the previous example. And they used that to try to predict the diameter of the tree. And do you think this is a better model? So you can see right away, if you look at this, it seems that there seems to be a lot less pattern in the residuals. So if we look at that part here, we could say, why is it a better model? There is no obvious pattern in the residuals. And now we could use this to predict. So to get the model, if you recall, we need to know the constant. So here's our output, right? And we need to know the log of the age, right? So if we we're going to write this, just like in our problem 12, we could say the change in the diameter, the beeping, please, is negative 0.86 plus 15.07 times the log of the age. Right? So if I do the work there on the calculator, I end up getting that comes out to be about 17 inches. Okay. So again, if I wanted to do that, we'd have to type in the log of the age. So this would be negative 8.6 plus 15.7 times the log of 50. And if I plug that all into my calculator, I'm going to get 17 inches. Do you not believe me? I will show you. So if we go to the calculator, I can just type in negative 8.6 077 and plus 15.07 times the log of 50. Voila, 16.99, which is about 17. All right, that's it for the week, kids. I will see you at office hours today at 2 o'clock.